Welcome to a lesson on the hypergeometric distribution. There are 5 characteristics of a hypergeometric experiment. Number 1, you take samples from 2 groups. Number 2, you are concerned with a group of interest called the first group. Number 3, you sample without replacement from the combined groups. For example, you want to choose a softball team from a combined group of 11 men and 13 women. The team consists of 10 players. Number 4, each pick is not independent since sampling is without replacement. In the softball example, the probability of picking a woman first is 13/24 because there are 13 women out of a total of 24 possible players. The probability of picking a man second is 11/23 if a woman is picked first. Notice how the denominator drops from 24 to 23 because there is one less person to choose from, and the numerator is 11 because there are 11 men. The probability would be 10/23 if a man was picked first. Again, the denominator is 23 because one person has already been picked, and now the numerator is 10 because the first person was a man this time, and therefore there are only 10 men to pick from. The probability of the second pick depends on what happened in the first pick. And then finally, number 5, you are not dealing with Bernoulli trials or binomial trials. The outcomes of a hypergeometric experiment fit a hypergeometric probability distribution. The random variable x is equal to the number of items from the group of interest. And we use a notation shown here to represent a hypergeometric distribution. We read this as x is a random variable with a hypergeometric distribution. The parameters are r, b, and n, where r equals the size of the group of interest or the first group, b is the size of the second group, and n is the size of the chosen sample. Remember, a random variable is capital X and takes on values small x. The connection between values and events, capital X is equal to small x, is the event that capital X takes on the value small x. And the probability x is equal to k is equal to the product of r choose k and b choose n minus k divided by r plus b choose n. And the mean is equal to the product of r and n divided by the sum of r and b. Let's take a look at an example. A school site committee is chosen randomly from 6 men and 5 women. If the committee consists of 4 members chosen randomly, what is the probability that 2 of them are men? How many men do you expect to be on the committee? To determine the probability that 2 of them are men, we want to find the probability x equals 2, and to determine how many men we expect to be on the committee, we need to find the mean. So to set this up, the random variable x is equal to the number of men on the committee of 4. The men are the group of interest, or the first group, which is why r is equal to 6. The random variable x takes on the values of 0, 1, 2, 3, and 4. We stop at 4 because the committee size is 4. And then because there are 5 women, b is equal to 5. Because we are choosing a committee of 4, n is equal to 4. Now we have all the information we need to find the probability x equals 2. Notice because x equals 2, k is equal to 2. In the numerator we have r choose k, which is 6 choose 2. 6 choose 2 is the number of ways we can choose 2 men from 6 men, times b choose n minus k. Well, b is equal to 5, the number of women. And then n minus k is equal to 4 minus 2, which is 2. 5 choose 2 gives us the number of ways we can choose 2 women from 5 women. In the denominator we have r plus b choose n. Well, r plus b is 6 plus 5, the number of men plus number of women, which gives us 11. And n is 4, which gives us 11 choose 4. 11 choose 4 is the number of ways we can choose committees of 4 from 11 people. And now to evaluate this on the TI-84. We need the numerator in parentheses, so we enter open parenthesis, and then for 6 choose 2, enter 6, math, right arrow to probability, select option 3 for combination, enter 2, right arrow, times, for 5 choose 2, enter 5, math, right arrow to probability, select option 3 for combination, enter 2, right arrow close parenthesis for the numerator, and then divided by 11 choose 4, enter 11, math, probability, number 3, and then 4, and enter. Let's first get the exact value by pressing math, enter, enter, which gives us 5/11ths, or to 4 decimal places, approximately 0.4545. And now we need to find the mean to find how many men we expect to have on the committee of 4 in general. The mean is equal to, we have n times r, which is 4 times 6, divided by r plus b, which is 6 plus 5. Simplifying, we have 24/11ths, converting to a decimal. We have approximately 2.1818. Let's take a look at a second example. A bag of marbles contains 13 red marbles and 8 blue marbles. Notice how there are a total of 21 marbles. If 5 marbles are drawn from the bag, what is the probability that 3 of them are red? How many red marbles would you expect in general when drawing 5 marbles? The random variable x is equal to the number of red marbles of the 5 drawn. The red marbles are the group of interest, or the first group, which is why r is equal to 13. The random variable x takes on the values 0, 1, 2, 3, 4, 5 because we are choosing 5 marbles. B is the number of blue marbles, which is 8. N is the group size, which is 5. To find the probability that 3 of the marbles are red, we need to find the probability x is equal to 3. Because there are a total of 13 plus 8 or 21 marbles, and we're selecting a group of 5, the denominator is 21 choose 5. In the numerator we have r choose k times b choose n minus k. r choose k is a number of ways we can select 3 red marbles from 13 red marbles, which is 13 choose 3, times, if we're choosing 3 red marbles, the remaining 2 marbles must be blue, and therefore the second combination is 8 choose 2. The number of ways we can choose 2 blue marbles from 8. And now let's go back to the calculator and evaluate this probability. The exact probability is 1,144 over 2,907. The decimal approximation to 4 decimal places is approximately 0.3935. To find how many red marbles we expect in general when drawing 5 marbles under these conditions, we need to find the mean. The mean is equal to n times r, which is 5 times 13, divided by r plus b, which is 13 plus 8, which gives us 65 divided by 21. And 65 divided by 21 to 4 decimal places is approximately 3.0952. Before we go, I also want to show how we can use an online tool to determine hypergeometric distribution probabilities. So following the link here shown on the screen, if we wanted to verify this probability, we enter the population size, which is 13 plus 8 or 21. The number of successes in the population would be the number of red marbles, which is 13. The sample size is 5 because we're drawing 5 marbles. The number of successes in the sample would be the number of red marbles we want, which is 3. If we press calculate, notice how it does verify our probability here at the top, approximately 0.3935. Also notice how this gives other probabilities for x less than 3, less than or equal to 3, x greater than 3, as well as x greater than or equal to 3. I hope you found this helpful.